In the last problem, we were talking about this idea of the base being a whole number versus a fraction. And in the problem we were talking about before, Zeno's paradox, or the Cookie Monster problem, which is basically the same concept, we were looking at, well, what happens if we take 1/2 to these various powers? Well, let's fill in the table. And a good question came up. Do we always have to use, could I start with 2, 1, 0, -1, -2? Oh my gosh, that feels wrong going that direction, but I could. The thing is for your table of values, you can choose whatever values of x you want. It's just that graphing x as a million is not on my graph. So typically we're using numbers around the origin. I actually think in a way it's easier to start out with a positive exponent in this case, because what is 1/2 to the second power? It would be 1/2 squared, right? It's 1/4. What about 1/2 to the first power? 1/2. What about 1/2 to the 0 power? It's going to be 1, right? Anything to the 0 power is 1. What about 1/2 to the -1 power? What happens when I take f of -1? I would have 1/2 to the -1 power. What would that be? The negative exponent, what does it do to the fraction? It says take the, oh, I thought it was called the reciprocal. Oh, just joking. No, it is the reciprocal. So what's the reciprocal of 1/2? 2. And then what about 1/2 to the -2 power? Is 4. Now, I guess what's really inconvenient about the way I've graphed it is the way I've done this table of values, I have to kind of go backwards instead of forwards, but that's okay. So if I start with 2, 1/4, we were talking about how it's really kind of hard to graph a fraction. Halfway, so here's 1, here's 1/2, halfway. Half of a half is a fourth. So if I have to the second power 1/4, right here, I have 2 1/4. That's plotted and labeled. Okay? So the first power is 1/2, so that's halfway. What is this special point here? The y-intercept. Good. Anytime x is 0, you always have a y-intercept. And so our y-intercept is 0, 1. I should label all of these to just show what that looks like. 1/2. And then as we have negative exponents, -1, 2, -1, 2, -2, 4. And you're actually noticing, what do you notice? What do you think if I have -3, what's my value going to be? Yes, -3, -3, 8. Okay, and it's going up in the negative direction and down in the positive direction. Do you see any asymptotes happening? Thoughts on asymptotes? Y equals 0 again, because this time as x gets bigger and bigger and bigger, we're getting smaller and smaller and smaller, just like the Cookie Monster's cookie, right? So our asymptote is y equals 0. What's the domain of this function? Is there any possibility that I shouldn't use a value of x? Would any value of x be a problem? And the answer to that would be no. I don't have a problem with any of these values of x. So our domain is all real numbers, and we write that as -infinity to +infinity. The parenthesis around the infinity means that that number is or is not included. Yeah, why can you not include infinity? Yes, exactly. You took the words right out of my mouth. It's a concept. It's not a number. It's exactly what I would have said. And then what's the range? And should I include the 0? I should not include the 0. The 0 is not included. And why does that make sense that the 0 is not included? That's why I have a parenthesis around the 0. Exactly, because we have that asymptote happening, and if you were to draw the dotted line for the y equals 0 asymptote, you can't even really see it because it's the same thing as the x-axis. So will you have an x-intercept? No. You can't have an x-intercept because we're getting closer and closer to x equals 0, but we're never getting there. Okay.